Now, in this lecture, we'll be discussing two important aspects of gradient. The first aspect is called directional derivative of a scalar. Let n cap is a unit vector along a particular direction. Then, component of grad of t along n cap, that is grad of t dot n cap, is called the directional derivative of the scalar t along n cap. This means since n cap is a unit vector and grad of t another vector, so the component of grad of t along n cap is given by, as we know, the dot product between grad of t and n cap. And this component of grad of t along n cap is nothing but the directional derivative of the scalar t along n cap. So the definition of directional derivative of a scalar stands as directional derivative of a scalar t along a vector n cap is defined as the component of grad of t along n cap. So this is the simple definition of directional derivative of a scalar. Now you see, if you write this dot product, that means the directional derivative, in terms of dot product between two vectors in abstract form, then this can be written as grad of t dot n cap is equal to magnitude of grad of t, magnitude of n cap, and cos theta into cos theta, where theta is the angle between grad of t and n cap. Now this is equal to obviously magnitude of grad of t into cos theta, as n cap is a unit vector, so magnitude of n cap is equal to 1. Now you see, the value of cos theta actually varies from +1 to -1. Now, for when cos theta is equal to +1, that means when cos theta attains its maximum value, then this directional derivative is equal to simply grad of magnitude of gradient of the scalar t, because cos theta is equal to 1. Now, for all other values of cos theta, that means all these values will be less than 1. So here the value of this directional derivative will be less than magnitude of grad of t. So this can be written mathematically as grad of t dot n cap is less than is equal to gradient of t, since cos theta varies from +1 to -1, right? Thus, magnitude of grad of t is the largest value of the directional derivative of t. So this is very important conclusion, which says the maximum possible value of directional derivative of a scalar is equal to the gradient of the scalar. Now the second aspect says gradient points in the direction of surface normal. Now how to prove this? For this, let us consider a surface in space which is given by phi x, y, z is equal to c, where c is a constant. And let us denote this surface by equation 1. Also let dr bar is equal to I cap dx plus j cap dy plus k cap dz lies tangentially on the surface phi, where dr bar obviously, as we know, is an infinitesimal vector in 3 dimension, right? So the total change in phi is given by d phi is equal to grad of phi dot dr bar. But as phi xyz is equal to c, a constant, so what happens? For a constant quantity, there is no change is possible for it, so that d phi is equal to 0, which can be written as grad phi dot dr bar is equal to 0, because d phi is equal to grad phi dot dr bar. And this means grad phi is perpendicular to dr bar, because the dot product between grad phi and dr bar is equal to 0. And this implies grad phi is perpendicular to the surface phi, and this again implies grad phi points in the direction of surface normal. So here is the proof. Thank you.